Forecasting and correlation. September 2021. Question 4A. Question 4, part A. Part A of the question, you're told that. Want us to do part A and part B. Now, explain the difference between correlation coefficient and coefficient of determination as used in regression analysis. So let's write. Let's write. See that? Correlation coefficient is a statistical method used to determine the nature and the strength, used to determine the nature and the strength of the relationship existing between the variables, the nature and the strength of the relationship existing between the variables. While coefficient of determination is used to determine how the independent variable explains dependent variable, how the independent variable explains the dependent variable. Yeah, so those are the difference between the two. That correlation coefficient shows the nature and the strength of the relationship existing between the variables. But for coefficient of determination, you see that it's also known as the explanatory power. It shows how the variable explain each other, how the independent variable explains the dependent variable, how the dependent variable is being explained by the independent variable. Number B of the question. A group of 8 students was tested in quantitative analysis and audit examination. The marks scored were as follows. So you have student A to H, the mark in percentage for both QA and audit required. Compute the Spearman's rank correlation coefficient and interpret the results. So how do we come up with that? So we have student A, B, C, D, E, F, G, H. We have the marks scored in QA. Then you rank them. Also in auditing, you also rank. And then you get D square. So QA you have 76. We have 43. We have 49. We have 84. We have 69, 53, 36. In audit, we have 82, 57, we have 75, 86, 68, 92, 43, and 53. And then from there, you rank. So the highest we have is, so you have number 1, you have number 2, then 69 they are tied. So we are number 2. So this one will be number 3, the other number 4. So take 3 plus 4, then you divide by 2. And 7 divided by 2 get 3.5. So that one will be 3.5, 3.5. Then we had reached number 4. So that means the next number is number 5. And this is number 5, number 6, number 7, number 8. Also rank for auditing. Now, so we have number 2, number 3. Then we have number 4. We have number 5. So we have so 1, 2, 3. Here you have number 4. Have number 5. Have number 6. Have number 7. We have number 8. So let's get d squared. You see that d is the difference in ranks. This is rank number 2, rank number 1. The difference is 1 squared, you get 1. 7 and 6, the difference is 1 squared, you get 1. 6 and 4, the difference is 2. 2 squared, you get 4. That's 1. 1.5 squared, you get 2.25. 2.5 squared, you get 6.25. 3 squared, you get 9. Get 1. Give me the total. So Spearman's rank, it's 1 minus 6 summation of d squared divided by n squared minus 1. So it will be 1 minus 6 summation of d squared is 25.5. Then you divide by n. There were 8 students. Then 8 squared we have is 64 minus 1. Have you done 1 minus answer? So 0 0.9. 69. 69. So now let's comment. Interpret the results. So there is a moderate positive correlation between the QA and audit performance. Yeah, you have the notes, so I want to remind you on how to interpret. Let's do another one. Let's try another one. November 2020, question 3B. November 2020, question 3B. And we are taught that in a choral music competition, 9 contestants were awarded marks in percentage using a music scoring grid by 2 assessors. The results obtained were given as shown in the table below. So we have the contestant from A to I. We have the first assessors and the second assessor. Those marks were in percentage. Required. The rank coordination coefficient and to interpret the results. The rank coordination coefficient. We have the contestant. A, B, C, D. Then we have the first assessor. Then you rank. Second assessor. And then you rank. And then the D squared. So the first assessor gave A 72%, 82, 79, we have 70, 67, 81, 78, 75, 65. Here we have 76, 80, 78, 73, 70, 85, 69, 83, 68. Then we rank. So can we rank this? Number one. Then you get D squared. Do you see there's a difference in ranks? This is number 6, this is number 5. The difference is 1. 1 squared, you get 1. The difference is 2. 2 squared, you get 4. The difference is 1. The difference is 1. The difference is 1. The difference is 1. 4 and 8. That means there was a very huge difference. 4 squared, you get 16. The difference is 3. 3 squared, you get 9. 990. So give me the total. So you have 34. So Spearman's rank, it's 1 minus 6, summation of D squared and N squared minus 1. So it will be 1 minus 6. Summation of D squared, we have it's 34. And there were 9. 9 squared is 81 minus 1. .7. So this shows there is a strong correlation or the relationship between the first assessor and second assessor awarding of marks. And then number 2 of the question. Number 2 of the question, you have to compute coefficient of determination. And coefficient is denoted by R squared. So you already have the Spearman's rank. Spearman's rank is 0.72, which is the same as R. And then you square. So what do you get? What? 0.52. So you can take a screenshot. September 2015, question 2B. A marketing firm employs part-time marketers. The hours worked and earnings of the 10 such marketers are shown below. So we have the 10 marketers, hours worked, then we have earnings. Required, there is square regression function relating to the hours worked and earnings. Interpret the results. And then number 2 is the Spearman's rank correlation coefficient. So number 1, we have to use the least square regression analysis. Least ordinary square regression. See that under linear regression, you need x, that's the independent variable. You need y, xy, as well as x squared. X is our independent variable. Here you have the hours worked, and then we have the earnings. Now the hours worked becomes your x because the hours worked will explain the earnings, but earnings cannot be hours. So therefore, a dependent variable is hours worked. 20, 48, 39, 28, 14, 60, 50, 62, 43. Then we have y. Y is a dependent variable, or the items being predicted, of which we have 5.5, 7.4, 11, 9.3, 7.2, 4.3, 13.5, 12, 14, and 10. So create your calculator. Create your calculator. You see that you press Shift Mod 3 equals. Once you insert the formula. How do you insert linear regression? So you press Mod 3 1. I've said Mod 3 1. Then you insert the values. We say that always start with x. So press 20, comma, 5.5 m plus 30, comma, 7.4 m plus. Now can you proceed until you get n is equal to 10? So once through, press on, press on. So now I want summation of x. You see that all summation is shift number 1. Shift number 1. What is the summation of x? 394. Give me summation of y. Sorry? 24. Give me summation of xy. For 192.5. Summation of x squared. 17.8. 8. Good. So now with that, now at a linear regression, y is equals to a plus bx, where b it's n summation of xy minus summation of x summation of y divided by n summation of x squared minus summation of x in bracket squared. So n, there were 10 marketers. Summation of xy we have is 4192.5 minus summation of x we have it 394 multiplied by summation of y, which is 94.2 divided by n. There were 10 marketers. Summation of x squared we have is 17,898 minus summation of x. Summation of x is 394. So we take 394 squared. Shift number 2. Shift number 2, then you replay forward. I want B. 0.20. That's B. So how do we get A? A is a summation of y minus B summation of x divided by n. Summation of y, we have it 94.2. Then B, we have it 0.2. Then the summation of x is 394 divided by n. Or n, there were 10 marketers. So shift number 2, then you replay forward, give me A. Sorry? 1.44. So that means our forecasting equation of the linear regression, y is equals to A. Our A is 1.44 plus bx. Our b is 0.2x. Then you can write in bracket, meaning that that your figures are in thousands. Good. So what if now you're told to determine the correlation coefficient, not the Spearman. Part 2 of the question wanted the rank correlation coefficient. So for the rank, you just need to take x, you rank, y, you rank, you get d squared. Now, what if now you have to compute? This one is not part of the requirement. Correlation coefficient. Correlation coefficient. Now, in this case, you want to determine, denoted by R, the relationship existing between hours and the salaries. We see that R is equals to N summation of xy, summation of x, summation of y, divided by the square root of N, summation of x squared minus summation of x in bracket squared. You multiply by N, summation of y squared minus summation of y in bracket squared. So just substitute N is 10. Summation of xy, we have 4192.5 minus summation of x, we have it 394 multiplied by the summation of y, which is 94.2 divided by square root of n, we have is 10. Summation of x squared, we have is 17,898 minus summation of x was 394. Then you square. You multiply by, now you substitute x now with y. So n, we have 10, summation of y squared. Can you press shift number 1? Shift number 1, we pray for how much is the summation of y squared? Yes? 985.08 minus summation of y, then you square. Summation of y we have was 94.2. Then you square. Shift number 2, we pray forward. Shift number 2, we pray forward. How much is our R? 0.199. 0.99. 0 point like that. Good. So that means, what does that mean? There is a positive, strong correlation between hours worked and the earnings. What if now you are now to compute the correlation coefficient of determination? Coefficient of determination, denoted by R squared. It's also known as the explanatory power. You see that R squared, just R times R. So it will be 0.99 U squared. What do you get? 0.9801. So how does that show? So it shows that 98% of earnings is being explained by the labor hours. Or you can also see that 98% of the labor hours explains the earning. So we can take a screenshot.